It's late on a Tuesday night in the middle of the Utah desert. A researcher is sitting alone in an old trailer on top of a mountain, rat-infested. No cell signal. Nothing around him for miles except sand and military fencing and equipment that barely works. He's watching a bank of monitors, waiting for something to happen. And then, everything goes off at once. Something had entered the upper atmosphere above him. Something so small you couldn't see it with the most powerful microscope ever built. Something moving at a speed so close to the speed of light that if you raced it against a beam of light for an entire year, the light would win by less than the width of a human hair. Not a rocket, not a laser, not a probe. A single particle, one proton, alone, from somewhere out in the universe. And the researcher stared at his data and said the only thing anyone could say, "Oh my God." The name stuck. Ask anyone what the fastest thing in the universe is and they will give you the same answer. Light. 300,000 kilometers per second. Nothing with mass can reach it. Nothing can beat it. It is the universal speed limit, and it has been that way since Einstein figured it out in 1905. That answer is technically correct, but it is also incomplete in a way that will rearrange how you think about speed and matter and the nature of the universe itself. Because here is what they don't put in the textbooks. There is a particle sitting in the record books right now, detected once, never explained, and it came closer to the speed of light than anything science has ever witnessed or created. 40 million times more energetic than the most powerful particle collider on Earth has ever produced. Moving at 99.9999951% of the speed of light. That is not a typo. Count those nines, and nobody knows where it came from. To understand what happened that night in 1991, you need to understand what cosmic rays actually are. Space is not empty. It never was. Right now, as you sit watching this video, there are particles raining down on you from every direction. Most of them are protons. The nuclei of hydrogen atoms stripped bare and accelerated across the galaxy by violent events like supernovas and black holes and neutron star collisions. They hit our atmosphere constantly, and most of them are harmless, low energy, ordinary. But some of them are not. At the very top end of the energy scale, there exists a category of particles so extreme that physicists have a special name for them: ultra-high energy cosmic rays. And even within that category, there is a theoretical ceiling, a hard limit on how much energy a particle can carry and still survive the long journey through the universe without being torn apart by background radiation. That ceiling is called the GZK limit, named after the three physicists who calculated it in 1966. The GZK limit said that nothing coming from beyond our local neighborhood of galaxies could carry more than a certain amount of energy. The cosmic microwave background, the faint afterglow of the Big Bang that fills all of space, would strip the energy away before it could ever reach us. So in 1991, when the Fly's Eye detector in Utah recorded a particle carrying more than 320 exa-electron volts of energy, it broke the limit, not bent it, shattered it. The energy measured in that single particle was 51 joules. That sounds small, but 51 joules packed into one lone proton is equivalent to a bowling ball dropped from shoulder height, or a brick landing on your toe, or a fastball moving at 90 miles an hour. All of that energy, in an object so small it makes an atom look like a continent. When the scientists looked at the data, they thought the equipment was broken. They spent a year checking and rechecking before they announced the result. And when they finally did, the physics community looked at them like they had lost their minds. But the data was real. Here is where things get genuinely strange. When you approach the speed of light, something starts to happen to time. Einstein's theory of special relativity tells us that the faster you move through space, the slower you move through time. This is not a metaphor. It is not philosophy. It has been tested and confirmed, and GPS satellites have to account for it every single day. For the oh my God particle moving at 99.999999951% of the speed of light, the time dilation was not mild. It was not even extreme by normal measures. It was almost incomprehensible. If that particle had traveled 1.5 billion light-years to reach us, from its own point of view, the journey took less than 2 days. Less than 2 days. From 1.5 billion light-years away. 1.5 billion years of cosmic travel compressed into 48 hours simply because the particle was moving fast enough. And consider this. That particle hit our atmosphere and collided with a nitrogen nucleus high above Utah. When those two things met, the collision was 200 times more powerful than the highest energy collision ever produced inside the Large Hadron Collider, the most expensive and powerful particle accelerator ever built by human hands, running for decades, with the combined effort of thousands of the smartest people on Earth. One random proton from somewhere in the cosmos outdid all of it without even trying. Here is the part that keeps physicists awake. A particle with this much energy should not be able to travel very far. The GZK limit exists for a reason. The cosmic microwave background radiation, that ambient glow left over from the Big Bang, acts like a fog that slowly saps energy from ultra-high energy particles as they move through space. It is why the limit was supposed to hold, which means the oh my god particle had to originate relatively nearby. On cosmic scales anyway. Probably within a few 100 million light-years. And because it was moving in a near-perfect straight line, barely deflected at all by magnetic fields, the impact direction should have pointed directly back at the source. So scientists looked. They looked in the direction the particle came from, and they found nothing. No active galaxy, no quasar, no gamma-ray burst, no black hole jet pointing our direction. Just ordinary background stars and empty space. One physicist described it as having a gorilla in your backyard throwing bowling balls at you. Except the gorilla is invisible. Since 1991, more ultra-high energy cosmic rays have been detected. More than 15 events at similar energy levels. One detected in 2021 and announced in 2023 was named the Amaterasu particle after the Japanese sun goddess. It carried 240 exa-electron volts of energy, also above the GZK limit, also from the direction of a region of space called the local void, an enormous near-empty bubble on the border of the Milky Way. There is nothing obvious in that direction capable of producing it. The best candidates include active galactic nuclei and the jets of supermassive black holes and extreme magnetars. But none of the models can fully explain how you get a particle to 320 exa-electron volts. Not even close. The universe is doing something we do not understand yet. Now here is where the title of this video comes back around. The oh my god particle is the fastest piece of matter ever recorded, the closest any known object has ever gotten to the universal speed limit without being a photon. That much is undisputed. But the fastest thing in the universe? That depends on how you define thing. Right now, at this exact moment, there are galaxies moving away from us faster than the speed of light. Not through space. Space itself is expanding. The fabric of the universe is stretching. And because of that stretching, any galaxy beyond a certain distance, roughly 14 billion light-years from us, is being carried away from us at a recession speed faster than light. Einstein doesn't mind. His rule only applies to objects moving through space. He never said anything about space itself, and space has no speed limit. At the very beginning of the universe, during the first fraction of a second after the Big Bang, there was a period called cosmic inflation. The entire universe expanded from something smaller than a proton to something unimaginably vast, in a sliver of time so short it barely registers as a number. The rate of that expansion was orders of magnitude beyond the speed of light. Space can do what matter never can. Since that night in 1991, the University of Utah has built something extraordinary. 1,500 water-filled tanks spread across 3,000 square kilometers of desert, part of a network that now includes the Pierre Auger Observatory in Argentina, covering a similar area. All of it looking for the next oh my god event, waiting for the gorilla to throw another bowling ball. And while we wait, the mystery deepens. Because the more we detect these extreme particles, the more we realize that something out there, something we haven't identified yet, is capable of acceleration so extreme it makes our best technology look like a child pushing a toy car down a hallway. The oh my god particle was one proton, one particle, one night, detected by accident in a rat-infested trailer in the Utah desert by a researcher doing a quiet overnight shift, and it changed what we thought was possible. The fastest piece of matter ever observed was not built in a lab. It was not designed or launched or engineered. It simply arrived. From somewhere we cannot identify, moving at a speed we cannot replicate, carrying energy we cannot explain, and somewhere out there right now, another one is on its way. Subscribe if you want more of this kind of videos.